Welcome to G Fun Facts Online. Have you ever been in a meeting, a thought bubbling up, a perfect solution to the problem being discussed, but you said nothing? Or maybe you've typed out a reply to a post online, read it over, and then hit delete instead of send? We've all been there. That moment of hesitation, that internal debate that ends with you holding your tongue, is called self-censorship. It's the often unconscious decision to withhold our true thoughts and feelings. But why do we do it? What is this powerful, silent force that molds our public selves, even when no one is explicitly threatening us? The answers are emerging from a fascinating and surprising field called neuro-economics, which is mapping the very brain circuits that make us choose silence over speech. Neuro-economics is a hybrid field, merging the precision of neuroscience, the behavioral insights of psychology, and the predictive models of economics. It throws out the old idea of humans as purely rational beings, and instead explores the complex dance between our emotions and our logic when we make any choice, from buying a coffee to deciding whether to speak our mind. Using tools like fMRI scanners, scientists can now watch our brains light up in real time as we weigh our options. And what they're discovering is that self-censorship isn't just about fear. It's a sophisticated form of mental accounting, a cost-benefit analysis happening in fractions of a second. It's a trade-off. On one side, the potential reward of expressing our authentic selves. On the other, the potential cost of social rejection, a damaged reputation, or even economic loss. Today, we're going to peer inside the brain and uncover the hidden neural mechanics of this universal human experience. At the very heart of self-censorship is our fundamental nature as social animals. We are wired for connection. For our ancient ancestors, being part of a group meant survival. Being cast out meant almost certain death. That deep-seated fear of social exclusion is not just a feeling. It's a powerful motivator etched into our neural hardware. Neuroimaging studies have shown something astounding. The experience of being socially excluded activates the exact same brain regions that process physical pain. Specifically, the anterior cingulate cortex and the anterior insula light up. This means that to your brain, getting left out of a group or being publicly shamed feels distressingly similar to stubbing your toe or burning your hand. Social rejection is a genuine threat to our well-being, and our brain treats it as such. And the brain's primary security guard against this threat is a pair of small, almond-shaped structures deep in your temporal lobes called the amygdala. You've probably heard of the amygdala as the brain's fear center, and that's a big part of its job. It's constantly scanning our environment for threats, and it's especially attuned to social cues. It helps us read facial expressions, interpret tone of voice, and navigate the complex web of social interactions. In the context of self-censorship, the amygdala acts as an early warning system. It flags social situations that could lead to negative outcomes. Imagine you're about to voice a controversial opinion. Your amygdala might trigger a jolt of anxiety, a rapid heartbeat, a sense of danger. It's screaming, "Warning! This could lead to ostracism." Studies on individuals with social anxiety show that their amygdala is often in overdrive during social decision-making. This heightened sensitivity makes them more likely to avoid social feedback and, as a result, to self-censor. So that feeling of dread when you consider saying the wrong thing? That's the powerful, ancient influence of your amygdala trying to keep you safe within the tribe. But it gets even deeper. Self-censorship isn't just about avoiding a threat, it's also about seeking a reward. And that reward is conformity. We often change our attitudes and behaviors to align with a group, and neuroeconomics has revealed this isn't just a conscious choice to fit in. The social pressure from a group can fundamentally alter our perceptions and valuations at a neural level. Scientists using fMRI have identified a network of brain regions that spring into action when our personal opinions clash with those of a group. A key player in this network is the posterior medial prefrontal cortex, or PMFC. Think of the PMFC as your brain's performance monitor or quality control officer. One incredible study found that when a participant's opinion differed from a group's consensus, their PMFC showed a spike in activity. It was literally signaling a conflict, an error message, that said, "Your view does not match the group's view." What's more, the strength of that PMFC signal could actually predict whether the person would later change their mind to conform with the group. A stronger signal meant a higher chance of conformity. In a follow-up experiment, researchers took it a step further. They used a technique called transcranial magnetic stimulation, or TMS, to temporarily quiet down the activity in the PMFC. The result? People became significantly less likely to conform to the group's opinion. This suggests our brain is programmed to treat social consensus as a valuable piece of information, almost like a socially derived reward signal. When our views deviate from the norm, the PMFC's error signal creates a feeling of cognitive dissonance, a mental discomfort that prompts us to reconsider our position. This mechanism is vital for social learning and cohesion, but it's also a powerful engine for self-censorship. The discomfort of social dissent is literally encoded in our brain's activity. But there's another piece to this conformity circuit: the brain's reward system. The ventral striatum is a core part of this system. It's the area that gets excited for primary rewards, like delicious food or a cash bonus. But it also responds to more abstract social rewards, like earning a good reputation or receiving praise. Studies show that the ventral striatum's activity is heavily influenced by social information. When you learn that other people agree with your choice, this region lights up, giving you a little hit of dopamine and reinforcing your decision. It feels good to be in agreement. Conversely, the prospect of disagreeing with a group, of facing potential disapproval, can dampen the activity in this reward center. From a purely neural perspective, this makes conformity the more attractive, more rewarding option. Your brain is weighing the satisfying dopamine hit of social agreement against the dull, unrewarding prospect of dissent. So, you have the amygdala screaming about the pain of exclusion, and the ventral striatum whispering about the pleasure of inclusion. Who makes the final call? This is where the CEO of the brain steps in, the prefrontal cortex, or PFC. This is the most evolved part of our brain, located right behind our forehead. It's responsible for our highest-order executive functions like planning, reasoning, and integrating all the different streams of information to make a final judgment. Two areas within the PFC are particularly important for the decision to self-censor. First is the orbitofrontal cortex, or OFC. The OFC is our effective decision maker. It's crucial for evaluating the potential emotional consequences of our actions. When you're considering speaking up, your OFC is weighing the potential satisfaction of authentic self-expression against the anticipated sting of social rejection that the amygdala is warning you about. It's running an emotional cost-benefit analysis. The second area is the dorsolateral prefrontal cortex, or DLPFC. This part is associated with more deliberative, cognitive control. The DLPFC is what allows you to override your immediate emotional impulses for a better long-term outcome. It's the part of your brain that's active when you choose to save money for retirement instead of splurging on a fancy dinner. In the self-censorship dilemma, the DLPFC assesses the long-term strategic advantages. It might calculate that conforming now will build social capital that you can use later, or that speaking your mind, while gratifying in the short term, could damage your career prospects down the line. And tying it all together is that region we mentioned earlier, the anterior cingulate cortex, or ACC. The ACC acts as the brain's central conflict monitor. When you consider expressing a dissenting opinion, the ACC lights up, sending an alert signal to the prefrontal cortex that there's a potential for social conflict. This signal prompts the PFC to engage its full analytical power, drawing on the fear signals from the amygdala and the reward signals from the ventral striatum to make its final calculation. So, we can break down the decision to self-censor into a simple three-step neuro-economic model. Step 1 is valuation. Your brain, primarily the OFC and ventral striatum, assigns a value to both options, speaking your true opinion versus conforming to the group. This valuation is heavily colored by emotional inputs from the amygdala. Step 2 is comparison. Your prefrontal cortex, alerted by the ACC, compares these values. It weighs the potential rewards of social acceptance against the intrinsic value of self-expression. And step 3 is action selection. Based on this comparison, the PFC makes a decision: speak or stay silent. This decision is then implemented, leading to the behavior we can actually observe. This entire neural process has a striking parallel in an economic concept called preference falsification. Coined by economist Timur Kuran, the term describes the act of misrepresenting your own preferences because of perceived social pressure. It's a strategic move to navigate the social world, where what we say in public doesn't always match what we believe in private. The theory proposes that we all have two competing desires. First, an intrinsic utility, which is the personal satisfaction we get from expressing our true, authentic preferences. Second, a reputational utility, which is the benefit we get from conforming to what we perceive to be the social norm. When the perceived cost of social disapproval, the damage to our reputational utility, outweighs the personal satisfaction of authenticity, we will falsify our preferences. We will self-censor. Neuro-economics gives us the biological basis for this model.